Hello everyone. Today I'm going to talk about some of the database topics. The topics of today's presentation are advantages of database approach, brief history of database applications, and when not to use DBMS. Coming to advantages of database approach, controlling redundancy. It leads to wasted storage space, duplication of effort, and a higher likelihood of the introduction of inconsistency. On the other hand, redundancy can be used to improve performance of queries. Indexes, for example, are completely redundant, but the DBMS helps in processing queries more quickly. The DBMS should provide the capability to automatically enforce the rule that no inconsistencies when data is updated. Restricting unauthorized access. DBMS should provide a security and authorization subsystem which the DBA uses to create accounts and to specify accounts restrictions. Then DBMS should enforce these restrictions automatically. Providing persistent storage for program objects. Object-oriented database systems make it easier for complex runtime objects to be stored in secondary storage so as to survive beyond program termination and to be relatively retrievable at a later time. Providing storage structures and search techniques for efficient query processing. Database systems must provide capabilities for effective executing queries and updates. The query processing and optimization module of the DBMS is responsible for choosing an efficiency query execution plan for each query based on the existing storage structures. Providing backup and recovery. A DBMS must provide facilities for recovering from hardware or software failures. The backup and recovery subsystem of the DBMS is responsible for recovery. The recovery subsystem could ensure that the transaction is resumed from the point at which it was interrupted so that its full effect is recorded in the database, representing complex relationships among data. DBMS must have the capability to represent a variety of complex relationships among the data, to define new relationships as they arise, and to retrieve and update related data easily and efficiently. Coming to brief history of database applications. Early database applications. The hierarchical and network models were introduced in mid-1960s and dominated during the 70s. A bulk of the worldwide database processing still occurs using these models. Relational model-based systems. Relational model was originally introduced in 1970, was heavily researched and experimented with in IBM research and several universities. Object-oriented and emerging applications. Object-oriented database management system were introduced in the late 1980s and early 1990s to cater to the need of complex data processing in CAD and other applications. Their use has not taken off much. Many relational data DBMSs have incorporated object database concept, leading to a new category called object relational DBMSs. Extended relational systems add further capabilities, example for multimedia data, XML, and other data types. Relational DBMS products emerged in the 1980s. Data on web and e-commerce applications. Web contains data in HTML, that is hypertext markup language, with links among pages. This has given rise to a new set of applications, and e-commerce is using new standards like XML, extended markup language. Script programming languages such as PHP and JavaScript allow generation of dynamic web pages that are partially generated from a database. New functionality is being added to DBMSs in the following areas: scientific applications, XML, extensible markup language, image storage and management, audio and video data management, data warehousing and data mining, spatial data management, time series and historical data management. The above gives rise to a new research and development incorporating new data types, complex data structures, new operations and storage and indexing schemes in database system. Also allow database updates through web pages. When not to use DBMS. Many inhibitors of using a DBMS. High initial investment and possible need for additional hardware. Overhead for providing generality, security, concurrency control, recovery, and integrity functions. Then DBMS may be unnecessary if the DBMS and database and applications are simple, well-defined, and not expected to change. If there are stringent real-time requirements that may not be met because of DBMS overhead, if access to data by multiple users is not required, when no DBMS may suffice. If the database system is not able to handle the complexity of data because of modeling limitations, the database users need special operations not supported by the DBMS. Thank you.